At this point, hopefully you've watched the first instructional video on solving equations, and you've gone through the example problems that were linked, because at this point we're going to be looking at solving equations with fractions, which is a bit more complicated, and it's going to be a lot easier if you've looked at several of those example problems first. Let's jump in and look at an example of an equation with fractions. So let's solve x plus 1/3 equals x over 6 minus 1/2. This is much more complicated than the equations in the first video. Not only do we have the variable appearing on both sides, but we also have 3 different fractions in this problem. Now, a fraction is actually a way of writing division. X over 6 means x divided by 6. 1 over 2 is 1 divided by 2. Remember, when we're solving equations, to get rid of something, we want to do the opposite of what was being done. So because these fractions denote division, we're going to do the opposite, and we're going to be multiplying. We're going to be multiplying both sides of the equation by some number, and the goal is going to be getting rid of those fractions. The number that we need to multiply by is going to be the least common denominator, or the LCD. So we're going to multiply both sides by the LCD. Now, the least common denominator is the smallest number that's a multiple of all of the denominators. Many of you have seen this before, and you know how to find the LCD, but if you've never done it before, what you want to do is you want to look at the denominators, and you want to find the smallest number that's a multiple of all of them. Some of you can just look at this and see that 6 is the LCD, but if you can't, we can actually write out the multiples of each of these numbers. Multiples of 3 are 3, 6, 9, 12. Multiples of 6 are 6, 12, 18, etc. Multiples of 2 are 2, 4, 6, 8, 10, 12, etc. And we can see here that 6 is the smallest number that is a multiple of all of them. 12 is also a multiple of them, so 12 could work as a common denominator, but we want the smallest number that works, which is the least common denominator. Anytime you have an equation that you're solving with fractions in it, you can get rid of the fractions by multiplying both sides by the LCD. This is an incredibly important rule, and it's really, really essential that you're always following this rule. So in this problem, we're going to multiply both sides by 6. The way that I do this is by putting parentheses around both sides of the equation, and then putting the number we're multiplying by on the outside. And the reason I do that is because we're going to need to distribute that quantity to each of the things on the inside of the parentheses. Remember, we're multiplying both sides by 6. That means that each term on both sides needs to get multiplied by 6. Let's do this multiplication and see how it works out. On the left, 6 times x gives us 6x plus 6 times 1/3. There's different ways that we can multiply a whole number by a fraction. The way that I do it is I multiply the whole number times the numerator and then divide by the denominator. So 6 times 1 gives us 6, and when we take that 6 and divide it by 3, it leaves us with 2. Let's do the same thing on the right-hand side. 6 times x gives us 6x, and 6x divided by 6 gives us x. Then we have minus 6 times 1 is 6. Divide that by 2, we get 3. So when we multiply both sides of this equation by the LCD, we're left with 6x plus 2 equals x minus 3, which is much simpler than what we started with because we no longer have fractions. Multiplying by the LCD should always get rid of the fractions in an equation and make it much simpler to solve. Now we have variable terms on both sides. We want to get x alone on one side, so what we need to do next is eliminate one of these variable terms. We can do this by subtracting x from both sides, because when we do that, on the right-hand side, the x's are going to cancel, and we're left with just negative 3. On the left-hand side, 6x minus x is 5x, and we also have that plus 2. And so by subtracting x on both sides, we end up with 5x plus 2 equals negative 3. Now, we want to get the x alone in the end, so we want to get this 5x term by itself. To do that, we need to get rid of this 2, and the opposite of adding 2 is subtracting 2. So we're going to want to subtract 2 from both sides of the equation. When we do that on the left, the 2's cancel, and we're left with just 5x. On the right, negative 3 minus 2 is negative 5. And so we have 5x equals negative 5. Now to get x alone, we need to get rid of this 5. X is being multiplied by 5. The opposite of that is dividing by 5. And if we divide both sides by 5, that gives us x equals negative 1, which is our solution. Now, there are many more examples that you can do in the link below, and I encourage you to do several of those examples so that you can get plenty of practice. But I do want to talk about one more thing in this video, actually 2 more things. We're going to call these identities and contradictions. These are going to be curious situations where we try to solve an equation, but something weird happens. Let's look at the first example. Let's solve negative 2 times x minus 1 equals negative 2x plus 2. Now, if we want to solve this, the first thing we need to do is to get rid of these parentheses on the left by distributing the negative 2. When we do that, negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. So we get negative 2x plus 2 equals negative 2x plus 2. Some of you might be able to see what's happening here, but I want to continue. Remember, when we have variables on both sides, we want to eliminate one of those variables so that we can get x alone on one side. To do this, we can add 2x to both sides because that will eliminate the x on the left. However, it also eliminates the x on the right. When those x's are eliminated, we're left with 2 on the left-hand side and again 2 on the right-hand side. So we end up with 2 equals 2. This is different from everything we've seen before because we always wanted to get the variable alone and have the variable equals a number. But in this case, the variable has disappeared, so it's impossible to get the variable equals a number. Instead, we have to figure out what it means to get 2 equals 2. Now at this point, when I teach in person, I like to ask my students, does 2 equal 2? And they say, yes, that's true. And then I say, what about on a Saturday? Does 2 equal 2? And they say, yes, on Saturday 2 equals 2. And I say, what about in Paris? Does 2 equal 2? And they say, yes, 2 equals 2. And they get tired that I keep drawing out these examples. And the reason I do this is because 2 is always equal to 2. This is always true, no matter what. And because these are equivalent equations, that means the original equation is always true, no matter what. X can be any number we want. We can plug it in, and it will always work. So in this case, because any number will work as a solution, we will say all real numbers, because all numbers are valid as solutions. I want to encourage you right now to pause the video, pick a number for x, any number you want, substitute it in, and check that the left and right hand sides are equal. You should get that they're equal to each other no matter what number you plug in. So we say that the solution is all real numbers, and there's a name for an equation like this that's always true no matter what x is. We call it an identity. All right, there's one more example that I want to look at where something else happens. Let's look at this example. Let's solve 2 times x plus 3 equals 2x plus 3. Again, we're in a situation where we need to distribute to simplify the left-hand side. When we distribute the 2 times x is 2x, plus 2 times 3 is 6. So we end up with 2x plus 6 equals 2x plus 3. Now again, we have variable terms on both sides. We want to eliminate one. So I'm going to subtract 2x from both sides. I'm doing that because it will eliminate the x on the left. However, it also eliminates the x on the right, and it leaves us with 6 equals 3. Does 6 equal 3? No, it doesn't. What about on a Saturday? Would 6 equal 3 then? No, it doesn't. What about in Paris? Does 6 equal 3? No, it doesn't. 6 is never equal to 3. This is never true. And because these are equivalent equations, the original equation is never true no matter what value of x you pick. You could plug in different values for x for the rest of your life, and you would never get the left and right hand sides equal to each other unless you made an arithmetic mistake. Because this is never true, no matter what x is, we say there is no solution. There is no value of x that would ever work here. And again, we have a name for this one as well. We call this a contradiction. An equation that's never true, no matter what number you plug in for the variable, is called a contradiction. You might encounter identity and contradiction when you do your homework in WebAssign or in another math class. I usually say that the answers here are all real numbers and no solution, but I would accept identity or contradiction because that tells me that you understand what's going on. You can't just stop at 2 equals 2 or 6 equals 3 and circle that as your final answer, because that's not a final answer. When you're asked to solve an equation, you're asked what values of the variable are going to work and make it a true equation, and the answers here are all real numbers. Any number will make this first one true, and no solution, no value of x will make it true. Again, please look at the videos linked below of example problems. The more examples you go through, the better you'll understand what's going on. If you do the first couple of examples, if you watch those videos and you feel like you understand what's going on, then instead of watching the other videos, you should try and solve those problems yourself and then use the videos to check and see whether you've done it correctly. This will give you very good practice and allow you to check and see whether or not you're doing them correctly.